Example 9. Find the derivative for each of these. So part A, f of x equals 3 times e to the x. So the derivative rule here, we would just, 3 is a constant, and then the derivative of e to the x is e to the x. Part B, f of x equals x squared plus e to the x. So the derivative for this function, first of all, the derivative of x squared would be 2x, that's the power rule, plus the derivative of e to the x is e to the x. Part C, f of x equals sine of x minus e to the x. So the derivative of sine of x is going to be cosine x, and the derivative of e to the x is e to the x, so minus e to the x. Example 10, a billiard ball is dropped from a height of 100 feet. The ball's height, s, at time t is the position function. S equals negative 16t squared plus 100, where s is measuring in feet, t is measuring in seconds. Find the average velocity over each of the following time intervals. So from 1 to 2 seconds. So first of all, let's take a look at this function. So this function, s, is the height, and t is time. So this function, negative 16t squared plus 100. So if 100 is up here, this would be a parabola turned upside down like this. And this is the position function. So after 1 second, we can figure out what the height of this ball would be. And after 2 seconds, we could figure out what the height would be. Okay, and they want us to find the average. They want us to find the average velocity. So the average velocity is going to be the slope of the secant line. Slope of the secant line is going to be average velocity. Where the actual velocity, or the instantaneous rate of change, or where the velocity is happening at one particular point in time, that would be the slope of the tangent line. Which is a derivative. This would be f prime of t, since our independent variable is t instead of x. So let's find the average velocity. So the average velocity, to find the slope between these 2 points, we're going to use y2 minus y1 all over x2 minus x1. Okay? And, you know, this is really t sub 1. This is really t sub 2, which is similar to x sub 1, x sub 2. So let's do this. Let's do s of 1 equals negative 16 1 squared plus 100 would be 84. And s of 2 would equal negative 16, 2 squared plus 100. So this would be 4 times 16, which is 64. Negative 64 plus 100 would be 36. So now we're going to find the slope of the secant line, we're going to do 36 minus 84 all over 2 minus 1. So this will be negative 48 over 1. And this is a velocity, so it's going to be feet per second. And the negative is just telling us that this is dropping. Example 11. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. Because the initial velocity of the diver is 16 feet per second, the position function of the diver is s of t equals negative 16t squared plus 16t plus 32, where s is measured in feet, t is measured in seconds. When does the diver hit the water? So again, if you think about the graph of this function, this is the coordinates. It's going to start up here at 32 feet. Okay, it's a parabola. They're jumping off a diving board, so it's going to go like this. Technically, the parabola would go this way as well, but where time is going this way. We're not going to go back into time. Okay, so when does the diver hit the water? So the water would be at this point here, because at this point here, it would be t comma 0, where 0 means 0 feet off the ground, or when it hits the water. So for part A, you're going to do 0 equals negative 16t squared plus 16t plus 32. And what you can do, you can divide each of these by negative 16, since there's a 0 over here, and this would still be 0 equals t squared minus 1t minus 2. Then we can factor this, and this would be t minus 2, t plus 1. So t would equal 2, and t would equal negative 1. Well, the negative 1 we're going to throw out because, again, we're not going to go back into time. What is the diver's velocity at impact? Okay, so to figure out the velocity at impact, we're finding the slope of this tangent line. This would be s prime of t. We want the derivative of this function. That will give us the slope of the tangent line, which is velocity. Okay, it's the rate of change of this position function here. So this is going to equal negative 32t plus 16. When we take the derivative of this function, And then we want to find S prime of 2, which would be negative 32t plus 16. This would be negative 64 plus 16 would be negative 48. And this would be feet per second.